Hi, and welcome back to Research Reviews. Today we're diving into a breakthrough that may change how we create artificial intelligence models. Imagine being able to combine the best parts of AI models like mixing ingredients in a recipe, but instead of making cookies, you're creating super intelligent systems that can solve problems no single AI could handle alone. If you want to build a cutting-edge AI model, traditional wisdom says you need massive server farms, months of training time, and budgets that would make Warren Buffett wince. We're talking millions of dollars just to get started. For most researchers, universities, and small companies, this creates an impossible barrier to entry. But what if I told you there's a smarter way? What if instead of building a model from scratch, we could take existing AI models and merge them together like combining strengths of different superheroes? Well, that's exactly what researchers from Sakana AI claim to have achieved. Sakana researchers have cracked the code on something called evolutionary model merging, and it's as cool as it sounds. Think of it like AI speed dating, but instead of finding romantic partners, we're finding the perfect combinations of models that work better together than apart. And here's where it gets fascinating. The researchers used evolutionary algorithms, which are basically programs that mimic natural selection, to automatically discover the best ways to combine different models. No human guesswork, no trial and error, just pure computational evolution finding optimal solutions. Previous model merging techniques required highly skilled programmers and a deep understanding of the model's design in order to find productive combinations. It was effectively more of an art than a science until now. The breakthrough from Sakana lies in understanding that there are two different ways to merge models, and both could be optimized together to create a more robust merged model. The first way is the parameter space merging, which involves blending the knowledge stored in different models. For example, a model that excels in a specific language proficiency and one trained in mathematical reason could be combined to work out math in a different language. And the other is data flow space merging, where you determine which parts of the model should process information at each step. Think of it like routing thoughts through different experts for refinement. These two approaches can work together, creating hybrid systems that are greater than the sum of their parts. Let me paint you a picture of what it looks like in reality. The researchers wanted to create an AI that could solve math problems in Japanese, a challenging task requiring both language fluency and advanced mathematical reasoning. They started with 3 separate models, one that was great at Japanese but terrible at math, and 2 that were math wizards but couldn't speak Japanese. Common sense says this should be impossible to combine effectively, right? Well, their evolutionary merging process created a 7 billion parameter model that not only solved Japanese math problems, but actually outperformed a much larger 70 billion parameter model on various benchmarks. We're talking about David versus Goliath situation where the smaller, smarter combination won. They also created a culturally aware Japanese vision model, an AI that can look at images and understand them within Japanese cultural context. This isn't just about translation, it's cultural intelligence that understands nuances that would be lost on Western trained models. This research isn't just a technical achievement, it has the potential to democratize AI development. Instead of needing Google or OpenAI level resources, researchers around the world can now create state-of-the-art models by cleverly combining existing ones. And think about the implications. Smaller countries could create AI models in their native languages. Researchers could combine domain expertise from different fields, the environmental cost of AI development potentially plummets, and innovation accelerates because we're building on existing foundations. Here's the technical beauty. The evolutionary algorithms explore millions of possible combinations automatically. They test different mixing ratios, different layer sequences, different connection patterns, all without human intervention. Essentially, no artist is needed in this process. The system even discovered that some combinations work better when you amplify rather than just average the models, insights that human intuition might never have found. The researchers hint at even more exciting possibilities, such as using evolution to select which base models to use in the first place, or creating swarms of specialized merge models that work together on complex tasks. We're also seeing this approach to work beyond language models. They successfully applied it to an image generation model, suggesting that AI could revolutionize AI model development across modalities. This research represents a fundamental shift in how we think about AI development. Instead of expensive, resource-intensive approach of training everything from scratch, we're entering an era where intelligent combination and optimization prevail. The fact that a 7 billion parameter merged model can potentially outperform a 7 billion parameter traditional model isn't just impressive, it's potentially paradigm shifting. It suggests that intelligence isn't just about the size, it's about the smart architecture and clever combinations. For the AI research community, this opens up entirely new possibilities. And for society, it means that AI development becomes more accessible, more diverse, and potentially more innovative as researchers worldwide can contribute without needing massive computational resources. And for society, it means AI development becomes more accessible, more diverse, and potentially more innovative as researchers worldwide can contribute without needing massive computational resources. These researchers didn't just make AI training cheaper, they fundamentally changed how we think about creating intelligent systems. The future of AI might not be about who has the biggest supercomputer, but who has the smartest approach to combining existing models. The future of AI is collaborative, and researchers at Sakana are leading the charge by making their work freely available on the global research community through open source data and code available now on GitHub. As always, stay curious, stay informed, and remember, the next AI breakthrough might come from cleverly combining what we already have, rather than starting from scratch. The revolution isn't always about building bigger, sometimes it's about building smarter. Want to dive deeper into the technical details? Check out my full research review at joshuaberkowitz.us for the methodology breakdowns, detailed performance metrics, and links to the original publication. Until next time, I'm Josh, and this has been Research Reviews.